Hello everyone and welcome to my first ever complete repair video about this Harman and Kardon amplifier slash receiver slash DVD player called HS250. The instructions I will give here are also valid for the model HS200, which is pretty similar to this one. Before we continue, this repair involves soldering, and fairly said, not the easiest part of soldering. So if you've never used a soldering iron in your life, maybe this repair is not going to be the right thing to do. Maybe you can ask someone who you know who is more familiar with soldering to have an eye on it as well. And also this repair involves working on the power supply section of this unit, which is mains powered, so depending on where you live, 110 or 230 volts, which can be lethal. So if you're not familiar with working with power supplies or working with mains powered devices, you shouldn't do this repair, because if you do something wrong it can be very dangerous and it can actually harm or even kill you. If you want to do this repair and you want to follow along, you do this at your own risk. I'm going to explain everything as plainly and as understandable as possible, but I'm not responsible for whatever you do. So you're following along at your own risk. The problem we're going to address here is that these receivers after some time will have problems with the audio output. So they will either not output any audio at all anymore to the speakers, or distorted, or some intermittent audio. And if your model is having and giving you this failure mode, then this repair could work for you and will actually most likely work for you. If you have problems with your subwoofer and not with your front speakers, this is a different problem, because the subwoofer has its own amplifier built in. So if just your subwoofer is having problems, it's not about the amplifier. This repair is just in case your amplifier has a problem powering your two front speakers. So before we start here, I want to demonstrate to you what the problem is with this unit. So I'm going to connect a simple speaker to it and show you that there is right now no audio output at all. I'm just going to use this speaker I got out of a television. It's going to do the job. Connect it to one of the outputs. It doesn't matter in this case which one. Turn the unit on. There is a compact audio disc inside right now. As you can see, it's turning on, it's reading the disc, and it starts playing automatically. So you should be able to hear something. But regardless of the voltage of the volume setting I take here, there's absolutely nothing coming from the speaker. So at this volume it should already be pretty loud, and there's literally nothing coming out of the speakers. So we know that we have a faulty unit here, and that the fault is within this amplifier, so it should be repairable. So before we continue, of course shut the unit down. Unplug everything from the back, the speakers, the input, everything. Most importantly, unplug the mains power cord. And just to be sure, you should leave this amplifier sitting like that, unplugged completely for, let's say, 30 minutes or 1 hour, to make sure that all the capacitors inside are discharged and there's no voltage left anymore. However, I'm not going to do this. I'm going to start off right here. So what you have to do first is get the top lid off. It is held in by 7 screws, or it could actually be 9. So first off, I start by removing the screws that are on the bottom side, 4 silver screws, pulling the sides on. Once this is done, I'm going to continue with the back of the unit. There are 5 more screws holding on the top cover. All these I'm going to remove as well. So now you have unscrewed all the 9 screws. You have to get the top lid off, which is not very intuitive. You have to pull it upwards from the back while pulling the outsides, the side panels, to the side. Then lift the back up. Ah, I forgot one screw. So now we should be able to lift the backside up, and then continue lifting the backside up until it's almost 90 degrees. And then you can lift the whole top cover to the top like this. Now we can take a closer look inside to see what the problem is here. Let's see if I can get that in focus for you. So right here, this is the power supply section of the unit. You see all these like battery looking type cylinders with the silver tops. These are called capacitors, more specifically electrolytic capacitors. And if you look closely, you can see that, for example, this capacitor has a little bulging in the top. So the top is deformed and also a little discolored, which means it's starting to get bad. If you look further, you can see that also this small cap over here has the same issue. So there's definitely signs of aging on these capacitors. So this is what we're going to replace. We're going to replace all of the capacitors on the power supply board, even if not all of them are faulty right now. Because when one of them fails, you know that they are kind of at the end of their lifetime, so all the others might also fail in the future. So we're just going to replace them all. And there's one more capacitor hidden right down there in the output section of the amplifier. And it's the same type as the capacitors in front, so we have to replace this as well. So to start the repair and to start replacing these capacitors, we have to get the boards out of the machine. And I typically start by removing this logic board up here. So you don't need to change anything on that logic board, but you will have to get that board out in order to get the amplifier board out. So this is what I would start with. In order to get that out, you have to unplug all these white ribbon cables that go into it. Most of them can be simply unplugged. Actually, all of these and the two here. But these two ribbon cables you have to be a little careful about because they are held in by some retainers, I will call them. So if you look closely, and if my camera is able to focus on that, you can see these brown bars on the side. So before you get that ribbon cable out, you have to pull these bars to the front. So you see there's now a little gap, and then you can easily slide the cable out. Same goes for this. So there's this black bar, you pull on both sides until it's coming loose, and then you can just pull the cable out like this. For the other cables you don't have to do this, but still you have to be careful to some extent, because these ribbon cables easily break if you apply the force in the wrong direction. So try to get in there with 2 fingers and just pull in the direction of the plug, so pull it straight upwards without bending the lead, the cable too much. Repeat this step for all the cables there are. So as you can see, also I'm not perfectly able to get these cables out in one piece, or yeah, I'm able to get them out in one piece, but not as nicely as I would like to be able to, since they are quite short, so they just fit in the length they are supposed to fit. So there's not much room for you to get your fingers in there and try to unplug them. But eventually you can manage it. So there is one trick about this cable here, because it's really short. What you can do is you can unplug the other end first, which is right beneath the board, and then unplug it from here easily. And then the last cable out like that. So now you have freed the logic board of all its cables. What you're gonna have to do now is unscrew all the screws. I'm gonna put the camera back on its tripod so you get a little more steady view than this. So this should be about in focus. So remove all the silver screws on the top of the logic board. I think it's 3 in total. Then turn the unit around, and you have to also remove the screws holding in the plugs attached to this board, which are in this case 3 more. Make sure once more that you unplugged all the cables, and then just lift out the logic board like this. Put it somewhere safe. You will not need it until the repair is done. So, because we have to replace this one little capacitor over there, we have to get the entire amplifier board out, which is on the back of the unit. So we need some room to work. So I will go ahead and also remove the tuner unit that's sitting here. So turn the unit around again and remove these 2 screws as well. And there it is. So the amplifier board is as well held in by screws on the board itself, and again by screws holding in the plugs. So I will continue remove the screws on the back. All the way there is 1 screw here at the subwoofer connector, 1 at the optical in, 2 in the kinch or RCA connectors, and 2 around the SCART interface. So I will go from left to right here. Remove all the black little screws. So here's where it gets a little tricky, because the screws in the back of the SCART connector are held in by nuts. So you can try just grabbing on the nuts with your hands, and if that doesn't work, use a pair of pliers or something to hold the nuts while you unscrew the screws. Otherwise the screw will never come loose, but just continue turning and turning. So, now all the screws on the back of the amplifier section are removed. Now there's some more silver screws on the inside. I think it's 3 in total, yep. So 1 over here, 1 over here, and 1 more right over here. So take them out one by one. A little note here, you should always have a screwdriver that's magnetic, like this one, so it lifts the screws out with no problem. If you have a screwdriver that's not magnetic, one trick that you can do is just attach a little magnet to the shaft of it, and it will magnetize the whole screwdriver. So just unscrew them having this little magnet. So as I was just saying, when my camera battery died, when you don't have a magnetized screwdriver, you can just attach a little magnet to it and then just have the magnet sticking on the shaft, so it will magnetize the screwdriver and will help you get the screws out. So the amplifier board is now loose. Before we can take it out, there's some more things we have to do. One thing is there are 2 connections between the power supply board and the amplifier board, which is 1 more ribbon cable that you can pull out just like the others, and 1 power cable with 2 lines, which is held in by a retainer. Just push it together with your 2 fingers and then try to get it out there by wiggling it a little back and forth until it's off. And also there is one more plug back here connecting the amplifier to the output terminals of the unit. This is also held in by a retainer. Eventually you can get it off right now. If that's not possible, you can do it while you're lifting out the amplifier board. I will try to get it done right now, but as you can see, it's not working. So now what you have to do is to get this whole board out, which is not easy because there are some parts like this heatsink on it which will obstruct your abilities to get it out of there. So what I will try first is to push it a little to the back, which I cannot do since again I forgot some screws. So after this is done, you can see that the board is moving back more or less on its own. So try to grab it by the heatsink and then try to move it back and forth and in some directions until eventually you get to a point where you can lift this whole thing out. I don't really have a special way of doing this. Every time I have to do this repair, I'm just starting over again and figuring some things out, that some work better, some not. Well, this is one of the instances where it's not going that well. So trying to do some more things and trying to unplug the mains cable from the back of the unit. And it gives me a little more room back here. So right now I have it more or less loose, but there is still speaker connection I could not get off before, which I'm going to remove now. And it's on there quite sturdy, which makes sense because it has to carry the whole current going through your speakers. So now we have the whole amplifier board out, and right here you can see this one capacitor that needs to be replaced. This is the only reason we took this out. But for now I'm again putting this aside because we are still not done here yet. There is still the power supply sitting in here, which requires the most work. And to get that out, there are again some ribbon cables, of which only one is attached right now, going to the user interface board in the front. You can just pull it as the other ribbon cables softly out of there. And then there are just the screws left. Again, Silverhead Phillips screws all over the place. Not going to show you the exact locations because I'm confident that if you're trying to do this repair, you're able to find screws on your own. I'm just wanting to present to you the whole process of the repair and what is it that you have to really do in the end, so you can figure out if this is what you want to do or if you just leave it for someone else. So it's 5 screws in total holding the main board, the power supply board in. Once you removed all these, you can check that the power supply is moving freely. And it's held in by another ring there, but you can just put it up like this and then get the whole thing out of there. And what you're then left with is a pretty empty looking amplifier. There is this plastic shielding in here, which is beneath the power supply. This needs to stay in place, and you need to put it in when you need to leave it beneath the power supply when you put it back in, because this is another insulation layer between the mains potential on the power supply and your touchable shielding. So you have to have that plastic shielding there in order to protect the user from any harmful voltages. So now you can put this aside for quite a long time until we finish the repair of the two boards. And one thing not to lose is also this little cable which was connecting the tuner, this thing here, to the logic board. Just keep that safe. So, to start with something easy, we will start with the amplifier board and this one capacitor that needs to be replaced there. I'm trying to get the camera a little closer here so you can see actually some part of the soldering going on. My tripod can hold this steady. So, there is the capacitor that we need to replace on this board. I will include a list or more or less a link to all the capacitors that you would need to buy if you want to go in here and replace the capacitors and so to do this repair. There are a lot of other capacitors on this board and on the logic board. These are also electrolytic type, but the main power in this unit is going through the amplifier section. So the main capacitors that wear out, like these ones, are the ones on the amplifier side and the power supply to the amplifier. So I don't care about all the other capacitors. They are the same age, but usually they last much longer, and replacing all these is just too much work here. So ignore all the other capacitors, just focus on these big ones, specifically on this one here on the amplifier section. So this is what we're going to replace here. As I said earlier, this repair is, in terms of soldering, not the easiest, because all the boards, so this board and also the power supply board, as you can see, are double-sided. So they have copper on both sides, and they have as well quite big traces because they have to carry a lot of current. So the thermal mass of these boards is quite high. So it's really not easy to get the solder flowing with your soldering iron, especially if you don't have a really big tip, and especially also if you don't have so much experience with soldering, because it's just quite hard to get things in and out of this board by soldering because of these large thermal masses. However, it's possible. So what I will do here first is I'm gonna take something to put beneath the board, because I don't want to completely ruin my table here. So just choose some paper or whatever with some schematic drawings, although they are not mandatory. And what I usually do first when I have to remove components of boards is to add some fresh solder to the pins. Because the old solder is usually very high temperature solder, and even though I'm not going to use leaded solder, I'm not going to use lead-free solder, adding some new fresh solder is going to make the solder joints flow way more easily and let me remove the cap way more easily. So as I said, if you've never soldered before, this might be hard for you. But if you have some experience, you will know that if you see one component on this side, you will be able to make out that these two pins are the pins corresponding to it. So these are the two pins I'm going to add a little solder to here. So now what we have to do is get the capacitor out. There are multiple ways to do this. The professional way would be to get a solder sucker or solder pump like this and remove the solder right now from the holes, from the vias, so the capacitor should just fall out from the bottom side. But on this board this is just not really feasible, so what I do most of the time is I heat one of the two legs and then pull the capacitor in a way that the leg will get pulled out from the hole. So if I heat up this pin and I pull this capacitor towards me, you can hear it click there out of position, and I'm going to heat up the other hole and push in the other direction. And right now the capacitor is almost loose. I'm going to continue again, do it one more time here, and now the capacitor is just held in by some glue that the company used. So it's more or less loose, you can just get it off like this. So this is the only capacitor we have to get off from this board. So we're done removing parts here. But the problem is there is still solder left inside the two holes here that we need to get out. But since we removed the capacitor and thus its legs from the holes, the thermal mass of the holes has decreased and it's now easier to get all the excess solder out. Right now I'm going to use my trustworthy €1.5 solder sucker. Just going to load it, start off with one of the holes, put the soldering iron over it, and I wait a little, not just until the solder I can see is flowing, but because there is more solder on the other side, I'm going to have to wait some more time until all the solder is flowing. And then, again with some skill and knowledge, you fail. So you continue by trying it one more time, get all the solder flowing, put your pump right over there, and that's our first hole. Continue with the second one. Just make sure you just wait some time, and in this stage you can put your soldering iron to a very hot temperature. Right now I'm sitting at something higher than 400 degrees Celsius, which is insanely much for the most soldering jobs, but for removing components that are faulty anyway, it really doesn't matter how hot they get, so just go for it. So on this board it's quite easy since it's just one capacitor. You can see that there is written on the capacitor voltage 50 volts and 1000 microfarads. These are the two characteristics you have to meet with your replacement part. So it has to be at least 50 volts, more is not a problem, less is. And it should be exactly 1000 microfarads. In theory a bigger one also works, so let's say 2200 microfarads also works. But since this is an audio section, you should match the capacitances with the original ones, so you should go for a 1000 microfarad 50 volt capacitor, and you should maintain its the distance between the two pins, because otherwise you'll not be able to fit it easily into the new board. But as I said, I will continue a link or a list to links of matching replacement capacitors in the end of this video. So as you can see here, the replacement parts I have, although they are the same electrical ratings of 50 volts and 1000 microfarad, they are way bigger in terms of height. However, they have the same footprint and the same distance between the two pins, so it's just fine, and the extra height is really not a problem because the heatsink is very high as well, and as long as you don't exceed the height of this heatsink, the capacitor will fit in the unit, no problem. So these are electrolytic capacitors, so they are not bipolar, they are unipolar. Means they are only able to maintain or to keep voltage in one direction. So you have to solder them in the correct direction. Proper capacitors will always have this strip on one side with minus sign. So this is the negative side. This is the negative pin and the other is the positive pin. On the board you can see, I don't know if you can see on the camera, but if you're doing this repair yourself you will be able to see that on the lower side there is a plus sign. And as long as you see the plus sign, you know that's fine. You just put the plus lead in there and the negative lead in the other direction. So in my case the capacitor has to go in somewhat like that. There you go. Another hint about the polarity is usually that the negative pin is a ground pin, and the ground is usually all over the board. You can see here where the positive pin has just a defined trace going in some directions. The negative pin is sitting in the center of a huge area that extends in all directions. So this is also a hint telling you that this has to be the negative pin and this has to be the positive pin. As you will see further on in the video, this doesn't apply always, but for this board as well as many others it applies. So to get that capacitor on nicely, the first thing I would do is I would bend the legs a little away from each other, that the capacitor will just not fall out. Then sit the board like this and just apply some new solder to it. General rule about soldering is it's very easy to get the legs warm because they are tiny. It can, and in this case is very hard to get the pads hot. So what you should try to do first is not to get the legs hot, but just put the soldering iron on the pad and heat up the pad first, get some solder on there, and once the pad is hot, it's very easy also to move on to the leg and then get solder everywhere. Not too much, not too little. And also don't hold your soldering iron on the legs forever, because eventually the capacitor will get hot and could get damaged. So try to get as much heat on the pad first before you actually go in there and also heat up the leg. I know this doesn't work every time, and I know the solder joints we're going to do here are not perfect, but trust me, they will get the job done and they will not fail in the near future. So, one thing I mentioned before, and you might have noticed, is that the manufacturer used some glue to keep the capacitors in place on the bottom there. I'm not going to do this because it's quite time intensive and there's not really any reason for that, because you normally are not shipping this unit overseas several weeks or something. You're just going to leave it sitting on your table or whatever. So you don't have to use this glue. But one thing I would always recommend is try to get the capacitors as flat as possible on the board. With this bending thing I did, you just prevent the capacitor from falling out. It's not really flat on the board right now. So what I do afterwards is I put one finger on the end of the capacitors and then do a similar thing as before, trying to get out the other one, but in the other direction. I heat up this pin and I pull it towards myself, so I push the leg all the way into the hole. Repeat that to one and the other side until I'm able to really press firmly on that capacitor, press it against the board, then reheat both pins, let go, reheat both pins, take the soldering iron away, wait until the pins are cold, and then put your finger away. So this means that you have soldered it in while being under pressure. So you push the capacitor to the board while soldering it in. So right now it's completely flat with the board and it's really sturdy. I mean, it's just having this little springiness inside of itself because of its length, but it's not bending anywhere. So this is the first capacitor that we had to replace. So one important thing that you must not forget right now is these legs standing out here. This happens sometime that you repair a unit, put it back together, and then you have these legs touching some of the metal casing, creating a direct short and burning everything else. So be sure to cut these excess pins off with some pair of nice side cutters that should have the cutting edge quite flat. But then again, you shouldn't cut the pins all the way on the PCB, because then you will rip the pads off. Just do it in a little angle that you're cutting about 1 or 2 millimeters above the PCB. Then it's nice and steady and the pins will not touch anything. So depending on how picky you are, you can go in there now with some flux cleaner or some isopropyl alcohol and clean all the leftovers of the flux here away, so it will look shiny and new as before. It's up to you if you want to do that, since there is no kind of moisture exposure happening to this board. Most likely there's never going to be a problem if there's flux left on it. So for example, I will not do it here, but you can use something like, as I said, there's special flux cleaner or just pure alcohol, and just put it on there, scrape it off with some brush or something, and it will look shiny and new again. So with this replacement, the amplifier board is done, the capacitor is on, and we can move on to the other 27 capacitors on the main power supply board. So a little more detail here. There is one capacitor that we will not replace here, and this is this one. It's from the same brand, that's correct, so you could say it's going to fail as well. But the thing is, this big one is the mains filter capacitor, so it's sitting right after the rectifier for the mains voltage. So this thing has to be oversized to some extent, and it has to meet some regulatory standards. So this thing is the only capacitor in here that is actually over-engineered and that will last way longer than these. In addition, these are usually very hard to get in a specific size. They are quite expensive, and they are also quite hard to solder because they have really big thermal masses and really big pins beneath them. So in my repairs, I'm never changing the mains filter cap, because in my experience this is never a problem. This leaves us with 27 more capacitors on this board. Most of them are in here. There are some small ones here, and there is one hidden away right in there, and we're going to replace this one as well. So before you start, you should think about the fact that you have 27 capacitors of maybe 6 or 7 different types. So you need to get a system so that you know which capacitor to put where after you remove them. So one idea, for example, is to take a piece of paper, do a little drawing of this board, and then just mark on this drawing every position of every capacitor type. Count in the end that you have all 27 on this board written down. Remove all the capacitors, and then looking at this drawing, put them back in one by one, every capacitor on its right spot. Another way is just going in there and removing only one type of capacitor at one time. So for example, go in there and remove all the I think it's 10 microfarad capacitors, and then after remove them all, put new 10 microfarad capacitors in. Once you've put all new in, start with a different type of capacitors. This is what I'm going to do here. I'm just checking that what I said is correct. So there should be in total 4 capacitors on this board with 47 microfarad 50 volts. And they are here, 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 and this one hidden away down there. And again, if you're familiar with soldering to some extent, you should know how to spot the other side of components, so to find their legs. And then, as I did before, just apply some fresh solder to the pins of these 4 capacitors. I'm going to do now. And sometimes you have to recheck what it is you actually want to remove and where exactly to find that part, which can be a little tricky sometimes, but you will manage if you are keen enough to follow until here. So these were 3 of them, and there is the 4th one. So what you can try here is that, because of the capacitors being quite smallish, you can try to heat up both legs at the same time and maybe push a little on the top and try to get the capacitor just falling out, which it doesn't want to do here. So again, I have to pull. With these small capacitors it's quite easy to pull because you can just heat up both pins at once pull the whole capacitor out at once. This is not possible for this one over here because this is the one that's tucked away under the heatsink, but as you could have heard, it just fell down when I heated up the both pins over there. So I'm trying to get this happening with the others as well. It's not happening here. So I have to get in there, try to grab a hold on that capacitor, heat up the two legs, and then just pull it out like so. So these were three of the ones I'm looking for. The fourth one is on this edge. So heat up both legs here, give it a little time to go all the way through the board, and then pull it out. So I have now removed 4 capacitors with the ratings of 47 microfarad and 50 volts. And it seems to me that one is here. So they are there, 4 pieces, put them away. So what I want to do now is put the new ones in, but before I can do that, I have to do the shittiest part of this repair, which is trying to get the solder out of the soldering holes. After some time and some effort, it will always work, but until then you will end up cursing a lot and eventually destroying 1 or 2 pads on the board, which is usually not a problem because you can always get the pads back from somewhere else. I have done this exact repair a couple of times now, so I can kind of make out what's possible and what's not, and still every time I do it, it's really not so much fun, the soldering part of it, when you know other soldering projects with just single-sided boards where you can easily get solder off just by merely touching it. This is a different part, so I'm failing miserably here on this one ground pad. It's just not coming on out of there. So what you can always do is you can add some new solder to get some more heat into that. And eventually you'll end up with a nice hole. Also make sure that there is not just a hole, but it actually looks round and there's nothing in it, so you can actually later on push the leg of the capacitor through. Because if there's some solder still in the hole, even though there is a hole, the capacitor might not fit and you will end up going back to desoldering the rest of the solder. So make sure that all the holes you do here are nice and clean. And another pad with a big ground plane next to it, which is going to be hard. Almost worked, but not quite. Yep. So 3 of the capacitors could be fitted in. Now for the 4th one, you should always load your desoldering pump. And there you go. So now we can repopulate these 4 capacitors. So grab your replacements, 4 capacitors, 47 mic 50 volts, and fit them in there. So again, keep an eye on the polarity. On this board there are different indicators than before. I'm trying to get this in shot somehow, which is a little hard due to my poor lighting here. So let's see. If you're watching this in HD, you should now be able to see down there the pad for capacitor EC505 and you see two things. You see there is this white stripe on one side, and there is also the capacitor symbol inside the circle indicating the plus. So this white stripe is another minus sign indicating the negative side, and the plus of the actual symbol of the capacitor is, of course, the positive side. So grab your capacitor, just match the white stripes on the capacitors with the white stripe of the board, push it all the way through without pulling it back out, and then bend the leads away from each other to keep the capacitor inside there. So I have to focus a little back here again. Okay, so put all the 4 capacitors in, always matching the negative side properly, because if you fail once, this specific capacitor will most likely go up in smoke shortly after you turned on the unit, and you have to go through all of this trouble again. So just double check every capacitor you put in there, that you put it in the right orientation. So now it gets a little tricky, and actually it gets a lot tricky, putting the last capacitor in its position beneath the heatsink. You could, in theory, get the heatsink off, but that requires to get all the semiconductors off of it, which then requires you to put the thermal compound on the devices again, which is really a lot of trouble. So what I would instead always try to do is first get the distance between the 2 pins absolutely correct. So check that it fits from this side without any resistance. Then also check the polarity of this capacitor, which is that the negative side is over here, so to the inside of the board, and the positive side is here, to the outside of the board. Double check that you have it correct, because especially replacing that capacitor is nasty. One thing you can do is get, I don't know if it's called pincette in English, or something like this to hold the capacitor like this. Now you want to hold it the way that the line of the 2 pins continues to your hand, and that the positive side is closer to your hand. Then you can operate it in there somehow. I'm sorry, I'm most likely not be able to show this on camera properly because I have to see it myself. So first get the positive leg in, which is closer to your hand. And then if you align the length or the distance of the 2 pins correctly, the other leg should also slide into place. Carefully pull out your tool to this side, so not to remove the capacitor again, and then without letting it slip, pull it once more inside and bend the leads away from each other to hold the capacitor in. So this was one of the hardest parts of the repair. If you have this capacitor in, the others are in that respect not so hard. So now you can solder these on. So grab your soldering iron, make sure it's not in sleep mode for some silly reason. If that is, power it back up. And then again, heat the pads first, apply some solder to the pads, and then extend the solder all the way until the pins. You can do it a little faster than I do it here, but you shouldn't take way more time, because again, you will end up heating up the component, which will not damage it, but it will start to wear it. If it's proper capacitors, it shouldn't be a problem, but still be aware that you must not put infinite amount of heat on the legs of the capacitor. So now I leave it up to you whether you go in there and cut off all the pins right now, or you leave them on until you have fitted all the capacitors in there, and then go over the board once and remove all the pins. It's up to you. So this was the first type of capacitor. Now I'm going to continue from small to big. So there is one more capacitor, quite smallish here, which is 68 microfarad, 50 volts. Notably, that's the only capacitor that we're going to replace that has a different color than the others, but nevertheless it's from a shitty Chinese company called Capcon, so it's as shitty as the other capacitors. And I don't care if it's faulty right now, I don't want it in there. So as you probably could see, it fell off, just like the others did, or one of the others, which is quite nice. So remove the solder. That was a fail. Remove the solder. It could work. So grab your replacement capacitor, which should be just a one-off. Yep. So exact same type, 50 volts, 68 microfarad. If the capacitors come on these tapes, one thing I would not do is pull heavily on that tape, try to get it off in that direction, because you might end up not ripping the pins out, but putting stress on the pins, which is not nice. So I will just peel off the paper like this, check the orientation of the capacitor, negative stripe on negative stripe. You cannot see any of this, I'm really sorry. This is not some EEV type shit here. I'm just going to do this because honestly I don't want to do this repair so many more times. I just want you guys to be able to do this repair if you need to. This is why I'm trying to record this, and I'm hoping it's working out to some extent, and it might be helpful to one or two people out there to get the amplifier back and running. So, since there was just this one capacitor, that's all we have to do. One more thing, I explained before that you can grab the capacitor and make it flat on the board, which is especially important for the big capacitors. Since these are so small, you don't have to do it. I will do it just once for this one because I like it more this way. But really, you just have to do it for the big capacitors because they otherwise could start bending back and forth until eventually the legs could break. This is really unlikely to happen, but it could happen on the bigger ones at some point in time. So I'm just gonna make sure that the big ones are flat on the surface. So now I'm going to continue with these two capacitors down there. They are from smaller height than the others. What are they called? EC513 and EC514. Again, figure out where their corresponding pins are. Apply new solder to the pins. With a little luck, the capacitors will fall out by themselves, like this one just did. And maybe the other one will also do me the pleasure. I think it did. No, it didn't. So try one more time. Yep, there it is. So these two are off again. So, same thing as always. Go in there, remove the solder left on the pads, or in the holes, in the drilling holes. Again, big ground planes, big problems, but if you really want to get it done, you will get it done eventually. And try not to get solder back into your holes once you clean them. There we go. These capacitors, 16 volts, 470 microfarads, should be these guys exactly. Same size, same everything. Again, make sure to not fuck up the polarity, because this will cause more trouble than it solves. Put these guys back in there. Watch out for the negative markings. Align the negative markings of your device with the markings on the board. Bend the leads away from each other. Grab the soldering iron and get some solder flowing. There you go. And yeah, there's this idea that you want to get enough solder in the holes to get it flowing until the other side or all the way to the other side of the board to get the best or the lowest resistance, the best conductivity. You can do that. The manufacturer clearly didn't do it. And if you try to do it, you might end up with putting way too much heat on your pins, which could create problems by heating up the capacitors. So I would not recommend that. I would just recommend you to get enough solder on one side to get a proper solder joint there, and you're good to go. So now what size do we continue with? There are multiple options, I think, because right now there are a lot of capacitors left here. So I think I will continue with the 470 mic 25 volts, which should be all these guys here. So all the ones of the specific height and the specific diameter. Let me count. That's 6, 9, 10, 11 pieces right here on this board. So I'm going to desolder all of them, or at least I'm going to try to do so. Here we go. And also a thing you should look out for, there are some SMD components here on the other side of the board, and when you hold your soldering iron at a too low angle, you might end up scratching or misplacing these components, which is not something you want to do. So just watch out that there are these really small SMD components that you don't want to tamper with. So I removed 3 of them, so 8 more to go. There are really a lot of them on here, but this is actually an advantage for the people trying to repair it, because when companies, big companies, design products like this that will be sold in the magnitudes of I don't know how many 100,000 or million of devices, they tend to always use the same type of capacitor when they can. So even though, for example, in this case, another type of capacitor with a lower voltage rating might have had done the job, they go for the same size or the same ratings for, in this case, 11 capacitors, because for them it's cheaper to buy a whole lot of the same type of capacitor than to buy 11 different ones, even if some of them might be cheaper on their own. So this is why you end up, or often end up, with a big number of capacitors of the same type in one device, which is handy for repair, because then you also can just order a big number of the same device, and you don't have to worry so much about where to put what and what to order from where and if it's available on that particular shop and so on and so on. So I'm about halfway done here. Still going. Yeah, there's this glue coming in again. So even if you have the solder flowing on both pads, you still might end up with a part that won't come off just because it's held in there by some glue. So just make sure that the 2 solder legs are free, and then just move it until the glue comes off. that fell off right nicely. This one doesn't. Okay, so the rest I guess I have to do manually. Oh, there's just one more inside. Okay, that's actually quite nice. So, if we count the one that just decided to fall on the floor, and the other ones that maintained on the table, it's 3, 6, 9 and 11 capacitors. So we got all of them out. So now there is a lot of solder removal to do. You can also, if you're keen enough, as I will try now, use some of these desoldering or solder wick to try to get it off. But the thing is, there is a lot of solder on these boards and it's hiding inside the holes, pretty much inside the drill holes. And the solder wick, while it's able to get the tin off the surface, it's not really good at pulling the tin out of the holes. So this is why I also end up again with my trusty less than €2 desoldering pump, which decides to puke on me once in a while. So get rid of that. And just continue cleaning all the holes. So I said before that this repair is also valid for the HS200 models, which it is. If you're doing the HS200 repair, you will find out that some of the capacitors I'm removing here and then repopulating here are missing on your power supply. This is not the case for the amplifier section, but the power supply just has some components not populated. So you do also not have to populate these yourself by this repair. So if you see that there is a capacitor which I'm removing here and replacing here that is not present on your board, just ignore it. I will, however, not make 2 shopping lists or 2 parts lists because this is just dealing about some cents. I will just link you to the same link so you buy the capacitors as well that you could use for an HS250 repair, and you will just end up with some spare parts afterwards. So the main thing I wanted to get across here is if there is a capacitor not populated on your board, just ignore it. Do not populate it yourself. Doing so shouldn't cause any harm, but most likely the capacitor is just going to sit there without any voltage and without any use. So just, if it's not on there in the beginning, leave it off. So I'm actually making quite some progress here. Not too many failures I had. So I had times where this was a lot worse, and some holes I just had to drill through in the end because I just couldn't find the patience to get the solder out properly. This is always one last option you have. If you have 1 or 2 holes in the end that you just cannot get the solder out, no matter how hard you try, just take either a proper drill with, let's say, a 1mm or smaller drill bit, or if you don't, you might actually use a screwdriver, for example with a really tiny Torx head, or how is it called? In Germany it's called Imbus, the one with the six flat sides. You can also use this one. Just grab one that's small enough and then just rotate it, pushing it against the board, and then eventually it will act as a drill and push all the solder away. This is of course not a nice way to go, and it will damage the board, so you shouldn't do it too often and too excessively, but I've done it sometimes when there was really a solder pad that just that day didn't want to let me get the solder off of it. I just drilled through it and was done. So, still making progress here. Yeah, one thing about fume extractors for a repair like this, where you're actually dealing with a lot of solder and a lot of heat, I would recommend using a fume extractor. There are these small cheap ones that just sit next to you or next to your board. for 30 bucks or something. They are quite noisy and they don't get the job done as well as some 600 euro professional thing, but they will get something done, and in this case I think it's reasonable. I'm not doing it right now because, as I said, the one that I have is also quite loud, and I don't think you would be able to understand what I'm saying here, and also I would get a little crazy talking against this thing. So right now I'm doing this repair without any fume extractor, which is bad, I know, but what you gonna do? You know, this is actually getting along pretty nicely. I would have expected this to take way more time than it takes now. I think from counting the capacitors we are about halfway done here in 1.5 hours, while doing it somewhat in a video blog kind of way, which is not bad, I think. So, one thing you can always do to make sure you have all the holes done properly is just take the board, hold it against the light and look through it from the other side. So every hole that you actually did will appear as a shining light, and everything you forgot will just be dark. So you can use this technique just to make sure that all the holes you needed to clean are clean now. Then get a whole bunch of replacement capacitors. Again, they look a little different. These are now smaller than the original ones, but nevertheless 470 mic, 25 volts. So put them in the right orientation. Especially here there is a little trickery going on, because you think they all go the same direction on the board, so like always negative to the left, but there are some exceptions because they are working with, I think they're working with symmetrical voltages here, so some of the capacitors might actually need to be reversed, so just have an eye on that. Because again, I cannot stress this enough, do not connect your electrolytic capacitors backwards. I don't know if you have the Electro Boom channel subbed. If you have, you know that he has one of his really old videos where he's showing what's happening when you do that, and with the old fashion of this blog, everything catches fire and explodes on him, so really don't do that. Always check the polarity markings. Luckily there are some on this board. Always check that you get them correctly. It's tiring after some time, but you have to do it as well as I have to do it right now. And always spread the legs on the back side away from each other so the capacitor will stay in place and will not fall out or go on a little trip. Almost done here. And even I, despite the fact that I have done this repair some multiple times, I always check and double check every single capacitor I put in here. Because really, it happens so fast that you just have your brain on standby for one moment, plug it in backwards, and your whole repair is looking like you fucked up. If you're doing this repair for yourself, it's not such a big deal, because you just have to go in here again and redo this one capacitor at least. But if you do it for a friend or someone, it might be really embarrassing, because you give the device back, it works for some hours, some days, and then there's just smoke coming out and people are gonna be angry at you and you have to explain, and don't do that. Don't go there. So if you're using leaded solder, this whole process will become a little easier, because as you know, leaded solder melts at a lower temperature, so you can get it on there easily without having to worry so much about damaging the capacitors. But as I do this, especially as I do this without a fume extractor, I'm not going for leaded solder here. So almost done with these capacitors. Now it starts to get a little messy because you have these legs sticking up everywhere, and the thing is your eyes cannot really see these things because some of them are pointing towards you, some of them are well lit, some of them are not lit at all, so you cannot see every single one of these, and sometimes you just try to get your soldering iron somewhere and it doesn't work because there is a leg in the way that you cannot see. So now I will also leave it up to you to either have the patience to go in there and try to get every capacitor flat on the board, because these capacitors I still would call them smallish, so again no problem of falling out, but since I can do it, I will just get them in there a little more nicely than they are now, just to have it looking nice and clean in the end. Yeah, that's about right. This gets especially tricky when you go to the ones that are tucked away between other capacitors and other components back here, but with some practice you're always able to get some finger in there and try to get them in. Oh, this is a coil, okay. What was I saying? Okay, so yeah, I don't think I'm going to do the rest, they are fine. So I think this was the type of capacitor with the largest quantity in here. If you're watching this in full HD or HD, you might notice that I'm not always properly in focus. This is because I just have manual focus on, because I don't trust my good old EOS 650 to focus on videos properly. It's not meant for video, but it's doing the job here quite nice, I think. But I just leave the focus on manual because I don't want it to go all funny on me at some point in time. So you might end up sometimes with shots that are not perfectly or not at all in focus. So be it. So now there are 3 capacitors with 2200 microfarad. This one, and this one, I think 16 volts. No, just 10 volts. So these are my next targets. So check again where they are. Give them some fresh solder. And these ones, they will not fall out as the others did, because the legs are physically so far away from each other that you don't really have a chance to heat them up both at the same time. So I'm not even trying this right now. First step is again to put some solder on. Then grab the capacitor with your secondary hand. In my case, my left hand. Oh, I fucked that thing up. Okay. And then just move it back and forth, just like this first one. This one has glue on it again, so it's a little hard to get off. But since you have to replace them, it's not such a big deal. The second one up here, they are now all pretty tucked away between other components, so it might be a little hard to get your finger in there, but if I can manage, I'm sure you will do as well. So my camera decided to pause the video again. Okay, I'm done asking why this happens. Still couldn't get one of the 2 legs out. Okay, there we go. So what happened here, as you can see, is I pulled too hard while the solder was not flowing. So I ended up pulling the leg out of the capacitor. This is something you normally would never do, because then you basically screw the whole capacitor. But since this was one we have to replace. No big deal. So again, something depending on you, there are these glue over pieces here that remain. You can clean them off, cutting them away if they bother you that much. I will not. I will just continue removing the solder from the 6 pads in total that we just removed. So, for some reason this is already clean. Sometimes you're just lucky and you just are able to punch the hole through there with the soldering iron itself, but not often. Yep. Yep. Nope. Yeah, I remember this is one of the pads that's really bad because it has two completely extending ground planes on both sides, which will just not let go. Trying to go here and it failed on me. Amazing. Trying the other one first. That actually worked. So some new solder here. Remove that shit. Yep. There we go. So now I think these are the capacitors. They are a little special when replacing. Yes, they are. So what these manufacturers from China like Capacitors usually do is they sell capacitors with a typical rating of this one like 2200 microfarads and 10 volts in a package that has a lower volume compared to the same capacitor from a good brand. And they can do that because they just are not reliable. They don't last that long. They are just built shitty as fuck. So they are just able to put them in such a small package because they don't care about the reliability and the age that these things can reach. So they just shrink it down until it fits and until the customer wants to buy it. So what I had to end up with here is replacement capacitors that are a little thicker from the diameter than the original ones. The spacing of the legs is the same, but the size, especially the diameter of the replacement capacitors, is larger, which will present a small, I don't want to call it problem, it's just something that's not so convenient when you put them in, because they will not fit exactly like the original ones did, because they have a slightly bigger diameter. So for some places it's not a problem. So for example here there is this coil around, but it's not really bothering so much. So we'll just end up putting the capacitor in and then bending everything away a little, and it's fine. The same goes for the capacitor up here. So again, do not forget to check for the polarity. So this one has no problem whatsoever. And if I remember correctly, the really interesting one is the one we're heading towards now. Let me just get some of this glue here off, because it really is getting in the way of that one capacitor there. So there you go. And the other one is fine as well. So now you can see that there is not really any space around this capacitor that the excess diameter is going to fit. So this one is just not going to be nice. But I remember that I managed to get it in there somehow the last time. So I should be able to get it down here as well. Yeah. It's not nice. So there is this one coil beneath it that's not letting me push it all the way in right now. So, although it's not in there perfectly and I'm pushing a little on the other components, I'm able to fit it in there somehow. The polarity looks correct, also from the connections on the back. So, once these three are in, there we go. Okay, so I think it's just 3 more types. Yeah, so there are these 2 big ones over here. Now let me actually check if they are the same. No, of course they are not. So then let's address these 2 guys here first. So right now you should definitely manage to spot the right pins on the bottom side of a PCB belonging to the capacitor you want to remove. And again, there is some glue, so you will need to go back and forth a couple of times until the capacitor is free and you can get it out. Luckily the glue on this unit is pretty old, so it's actually not sticky anymore, it's just completely solid, so it just breaks off entirely. So that's actually quite nice. So these are also quite bad because they have large thermal mass again. That actually worked, first try. A little other trick you can follow is if you have multiple holes that you have to clean and some of them are on the same trace, always go along with all the holes on one trace, because the heat that you put on the one hole in that trace will conduct through that trace to some extent to the other trace, to the other hole in the trace. So the other hole in the trace is also a little warm by the moment you get there, if you do all the holes of one trace after each other. So these 2 were, don't let me lie, 2200 microfarad again, but this time 16 volts. And there also the cheap Chinese manufacturer decided he wouldn't go for a smaller package. So replacement parts, exact same size. Put them in there. Bend the hole, bend the legs. Check the polarity again. And you should be good to go. So all capacitors from now on I would definitely consider big enough that you need to make them flat on the board in the end. So as described before, after you soldered them in for the first time, turn it around, heat the pads up once more and push them all the way in, side by side, until they are nice and flat and holding themselves in properly. Yep, just like so. That looks good. So now we have last 4 capacitors. These 3 are the same type, and this one is the biggest one, which has the bulging on the top of it. So right now I'm going to remove all of them, because seriously, I want to get this done at some point in time. So you can see there is already a little tin on the traces, which usually helps you put more tin on it. And the reason for that is these are the main power traces providing power to the amplifier section. So this is where all the power is getting delivered to the amplifier. So that they're using this extra tin on the traces just to get a little more current handling capability and a little less surface resistance on the traces, which is a cheap way to do it. So right now I'm trying the other way around, so I'm trying to get the solder off with the component still in, but this will not work, especially not here. So I will just go back to my old style of heating one end, clicking the capacitor up, heating the other end, clicking it down, up, down, and it's loose. Repeat that for all the capacitors in your set. Throw it away, because fuck you. And last but not least, this big guy here. And one more sign that tells you that this capacitor was getting bad is you do not only see the bulging on this side. If you look really closely, you can also see it bulged over here, and it actually pushed the bottom out of the casing. So this one is definitely going bad. So, cleaning 8 more holes, and hopefully that's it for today. This is one of the occurrences where you think that the hole is good, but it's not round, so there is still some solder left in there, which you need to get out. So heat it once more, and then pray, and it fucked up again. This could be good enough. If you're not sure, it's always useful to check the hole is good before you stop cleaning up the other holes, so that you're just in the middle of the task. And you can see, not able to get that in there. So still some solder left in. In these extreme cases, you can just leave the soldering iron sit on that stupid little wire for 10-15 seconds until everything is smoking and boiling, and then just try it, and again, not enough. So this is one of the cases where I might go using a drill or something, because really I don't see this getting clean anytime soon. Nope. So now you get to see what I meant by this cleaning technique. Take a screwdriver that's not too worthy to you, because of course you're gonna wear it a lot by this. And I'm just going to use the smallest torque bit I have. No, actually not. I'm just going to use this six shape thing and just put it in there, rotating it, and then push firmly but not too hard on it until it just goes through. And that also gets rid of the excess solder, which of course is not the proper way to do, because you're not getting rid of the solder, you're just pushing it to the sides, deforming the board, which is not a good thing to do and will cause problems if you do it too oftenly. But what you gonna do? So I'm hoping this was the hardest pad, because it was also on the biggest capacitor in this set. The others so far look to come off nicely, and that being said, I fucked up. Nope, not working. Yes, sir. 2 more. And again, this is my first repair video. I have absolutely no idea how this turns out on the camera itself or on YouTube, whatever. I can just occasionally look on the screen of my camera, see that everything is more or less in focus or in the frame. But apart from that, I have no idea what you can see, how well you can see it. Well, this is not meant to be a soldering tutorial. This is just meant to be a video showing you what this repair here involves, what's the problem, what are the steps, so you can do it yourself if you feel confident. This is not a complete guide on how to solder everything on this board. So, 4 last capacitors, and again, also here, check the polarity. On these ones it's most important because they hold the most charge and thus the most energy. So if they decide to go up in smoke, you have smoke everywhere. But if you get the idea of the circuit here, it's quite reasonable. You have the negative pin always to the outside of this little semi-cycle and the positive pin thus always on the inside. So the capacitors in the end look like this. Yeah, not in the end. So I'm going to separate the legs again. Now on these capacitors you really want to be sure that there's a good connection. So if you see that the solder joint you did is not really nice, really try to go in there and redo it, because these capacitors, as I said. So what I did while my SD card was full and I had to wait about 30 minutes until my USB 2 connection could copy all the video data off of it. What I did is I put the last capacitors in flat with the board. They all are nice and steady. They don't move around. What I then did is I had the very satisfying duty to cut all the pins of the capacitors off, so the board is now flat. And what I also did is I cleaned it this time with isopropyl alcohol. Reason being is, when I use this solder pump, it always has these little sharpnels of tin falling out of it. So it's like putting little sharpnels, little pieces of tin everywhere on the board that stuck in the flux, so they stuck to the board. And if you have bad luck, these little pieces of tin can actually create shorts, which I of course wanted not to happen. So I went in there with a nice old toothbrush, put a lot of alcohol on here and then just scraped across the whole board, which was enough to get rid of all the flux and thus of all the little tin shrapnels hidden inside of it. So now we have also the power supply completely done. All the new capacitors are in. And now we can start reassembling the whole unit, hoping that it will give us some sound output once we put everything back together. And I also cleaned my desk a little because it was a little messy. So, coming back to this thing, what I would do now is put in the amplifier first. Actually, it would have made more sense in the beginning to get the power supply out first and then get the amplifier board out. We did it the other way around. You can do it however you like. It's possible in both ways, as you saw. So, the first thing you have to reconnect is this cable. This cable from the speaker terminals. It can only go in one direction, so there's really nothing you can fuck up there. Just push it all the way until it clicks into place, because it has this little retainer. It will at some point click into place. It just did. Then carefully, without damaging the cables and everything, try to get the whole amplifier board down where it was, which again is a little tricky because you don't have much room and this board is full of components. So it's in there now. What you're gonna do now is you're gonna put first the silver screws in on the PCB itself. So usually the rule with screws is don't screw a single screw in all the way. Just put every screw in the corresponding hole, screw it so that it's just flat on the board, but do not apply any force yet. Reason being is that you want to be able to move the board if you figure out that the last screw you want to put in is not be able to fit in because it's misaligned. Then you can still move it around a little, and then when every screw is in place you can start tightening them. There is no torque really required to put these screws in because again there's no mechanical stress on these, so just put them in reasonably tight but not with any severe force. Once these 3 silver screws are in, continue on the back side. You basically see where the screws belong because usually when you undo them you scrape off a little of this black color, black paint on the back, so you know where a screw belongs. And if you don't, you can go back to the beginning of this video. So all these screws until here are quite easy. Now you have to take the 2 screws with the finer thread on them for this SCART connector, because as you might remember there were these nuts holding them. So you have to get the nut somehow on the back end of the screw and then screw it in. And you should be able to let go of the nut at some point when it's reasonably tight together, and then the nut will just hold against the case and it will tighten itself without you holding it, as it did in this case rather nicely. Repeat that for the other side of the SCART connector. And you're done on this section. So then I'll try to get that in view as good as possible. Get a little more height on this tripod here, while still maintaining a proper angle and some focus. So one thing you must not forget now is this little tuner unit we took out to be able to service it a little better. It can only go in one way because of the actual tuner input. So again, take some screws, the black ones with the smaller head, not with the wide head. These are just for the case itself. And they should go in nicely. If they don't try to force them in. If they don't go nicely, get them out again. Try to put them in really straight, and then they should screw in without any effort. Yeah, that happens when you don't put them in straight. Can always force them to go straight if they are not really willing to go in the beginning. There you go. So one thing I would do now is to put that little flat flex cable back in that we took out in the beginning. If it has this shape, like so, it has to go in this way. You will figure that out later if you do it wrong, but it only makes sense this way. So, and with these flat flexes, there's a lot of things you can do wrong if you try to plug them in. Again, the most important part is not to bend them, especially not on this corner here, but instead to just push them in straight. So I will try. I cannot really demonstrate it here that good, but you will notice yourself. Just get 2 fingers, one above the flat flex, one beneath, and then just push it evenly so that it doesn't bend, but instead just can move forward, and it will move forward into the socket where it belongs in. So now I would put in the power supply and the logic board at last. So with the power supply, as I said in the beginning, there is this plastic cover on the bottom. Leave it sitting in there, leave it exactly in the position it was around all these screw terminals. The power supply only makes sense to put it in one way. You will figure that out. And if you're not sure, the Harman Kardon name has to be here, nowhere else. And since there is one screw hole actually holding the board in before you screw it, it's actually sitting in there quite nicely before you even get the first screw done. So when it's sitting in there and you see that this plastic shielding is properly around the mains input section here, you can start again by taking the silver screws on your hopefully magnetic screwdriver. First of all, put all 5 of them in there without any pressure, without any torque. Once these 5 screws are all in place and you don't drop any of them, you can go further and tighten them all up. Again, there is no need to squeeze the board absolutely to its limit. Just screw them tight enough so they will not come loose by themselves, and you're good. Don't worry too much about these screws. So then, at this stage, there's 4 things you need to reconnect. The first thing is the mains power plug coming in here. It has its correspondent plug socket right on the power supply. It also clicks into place. There is this connection cable from the power supply to the amplifier board, also clicks in place once you get it. There's this flat flex going to the front control panel. 2 or 1 finger above, 1 or 2 fingers beneath, and just pushing it firmly forward until it slides in. You will get a feeling at some point when it's completely in. Don't overdo it. And the last thing is the data cable down here between the power supply board and the amplifier board. 2 fingers, both sides, gently pushing it forward until it's all the way in its designated socket. Now, last but not least, we have to get the logic board back in and all its connections redone. So first, we have to place the logic board on top of its corresponding screw holes, making sure that all the cables are not beneath it, but instead are coming up right next to it, so you will be able to plug them in later. Then align the board until all the 4 screw holes match up. There is actually something going on with some metal heads penetrating through the board to get the alignment done before you even screw. For some reason they don't like me today. They really don't. Yeah, just try to not force it into place. Look around where the problem is, move it a little back and forth until eventually all the screw holes more or less match up. Then again, start with the silver head screws. Get 1 in each screw hole. Screw it just enough to hold the screw in, because these metal parts of the CD assembly are actually able to bend, as you can maybe see. So the screw holes might not align from the beginning. So it's always good to have some flexibility if they don't line up in the beginning. So you can still move the board around a little and then bend the metal pieces back and forth until all 3 screws are in their corresponding holes. And once they are, again, tighten them up to a reasonable amount, just enough to keep them from loosening themselves up. So now, one of the parts I dislike the most is getting all these flat flexes in, because again, as I said, there is not much how is it called? The cables are to pretty precise lengths, so there is not much play, not much room where you can get your fingers in between. So you have to be really careful not to pull them or not to misalign them. And at some of these you cannot, as I said, get 2 fingers on both sides. So you just have to be really careful. They have this blue thing which is stiffening them, which is giving them a lot of more mechanical strength. So try to use that and try to get some force from the top to the bottom on these But again, never overdo it. If you notice it's not going, then maybe pull it out again, try it again with a different angle. Because when you break one of these flat flex cables, the whole repair is going to be a lot more difficult, because these flat flexes are not some standard parts you can just order. They are more or less specifically made for a certain connection in a certain device. So you have to find a reseller that sells exactly that cable for exactly your amplifier, which is, frankly speaking, very hard. So the two most difficult ones, I would say, are the ones right here in the corner. So I will do this one. Actually, I will do this one first because it's the most difficult, because this was also the one coming from the tuner. It has absolutely no slag. That was the word I was looking for. It has absolutely no slag. So you have to really just put it in there, just push on top of it and hope you don't break it. I'm a little over dramatizing it here, maybe because I never broke one of these cables, but it's really something to look out for, because as I said, if you break one of these cables, you're pretty screwed and you have to do a lot more work than I just did here. So now the last two have these brackets. So make sure the bracket is pushed away from the connector while you put the flat flex cable in, like this. And again, you will notice when it's at its stop, so when it cannot go further, and then pull both sides of the bracket at the same time into the socket to secure the plug there, to secure the connection. Make sure that they are not on an angle, but you can see the individual pins on here. Make sure they all align with, perfectly with the end of the connector. Otherwise, if it's on an angle, it might not work. And then secure it by pushing the bracket into the socket. I'm going to redo this because I don't like the way it looks, but that's actually correct. So it has to go in just like that. And then just close it. So one thing I will do right now, because until this point I have not tested if this repair did anything good to the device. I will do something that you can do, again, if you're keen enough with this high voltage stuff, because remember, when I plug this cable in, you have mains voltage more or less everywhere here, and you could accidentally touch it. So be really careful. If you do this, you're doing so at your own risk. If you touch the wrong thing, you might kill yourself here. I'm trying not to do that. So first things first, we see that there is this red light here indicating that the amplifier itself has some sort of power. So right now I'm going to turn it on, see if it comes on, if the display comes on, and it's looking good. It's showing me display there. It's showing me that it's reading the CD. I'm actually going to take that CD out because I don't really know what's on there. And I'm going to get a CD where it's actually some music on it. Get my crappy speaker here, connected to one of the outputs. Put some decent music in there. And fingers crossed that this actually fixed our problem. And there you go. We have some sound. I'm not sure how much of this sound I can show you before YouTube decides to put my first repair video down because of some copyright infringements, but I just want to make sure that you hear just that there's music coming out of the speaker as I'm turning the volume up. And just for kicks, I'm also going to take the other output, but really, since this is just a single chip solution in here, if one of the channel works, the other works as well. There you go. Okay, so what this test shows us is that the repair we did was until this point successful. So we had no sound before, now the unit is able to provide sound again. So we can now proceed closing the lid. if for some reason you did this test, then also again, wait some time right now before you put the casing back together. Otherwise you put yourself to the risk of getting shocked, even though the mains is unplugged, because this capacitor here holds up to 400 volts DC for quite some time, even after you disconnect the unit. Just keep that in mind. If you're doing this, you all do it at your own risk. So putting the top case back on is actually as just the thing we did but reverse. So have it like 90 degrees upwards, try to fit it inside the cutouts, and then lower it to the back and make sure that it stays aligned here. It might flip, it might come out of these connections and will present a gap, then just like it did here, just try to get it, wiggle it a little bit back and forth until you eventually get it to get back on there. Okay, I have to redo this. And since I have to redo this, I'm going to talk a little bit about this amplifier. Maybe you don't want to hear this, but I always find it interesting when I find out these things. Harman Kardon, as you know, is a quite famous brand. They are popular, they are supposed to be a very good manufacturer for very good audio gear especially. And I've never bought this thing myself, but I'm sure it costs half a fortune to get this amplifier. And it looks all fancy with these big goldish plugs here that you can, by the way, get for about €2 from China. It looks very nice here and you think, oh, it's really a powerful unit in such a small form factor. But really, in terms of an amplifier, I'm an electrical engineer and I know a little bit about audio amplifiers. And all this audio amplifier comes down to is a little integrated circuit right beneath this heatsink, which is most probably a good quality brand. It's most likely Texas Instruments or Philips or something. But it's nothing but an integrated circuit stereo Class D amplifier. And if you Google it a little bit, you will find out what Class D is, and that it's really the cheapest and least professional or least audiophile amplifier technology that's out there. So this is really a cheap solution that Harman & Kardon did here. I mean, it's nice that they could fit it all in this relatively small form factor, but really from a technical point of view, this amplifier is nothing special. Every like $20 radio for your kitchen that you can get has the same amplifier technology inside. So I always find it interesting when you see this unit, oh, it says Harman Kardon and it's all black and silverish and it has these huge plugs and it's so good, and I don't say it sounds bad. I actually think it sounds quite okay because it's a decent Class D amplifier and they did nothing wrong. But it's just nothing really that you should be so, I don't know, so enthusiastic about, because this is really, from a technical point of view, not a good amplifier. It might sound quite good, it might be okay, but it's just nothing special of an amplifier. This is something you immediately see when you see this heatsink and you see that there is just one integrated circuit under there that's doing all the magic. That's not a really good amplifier. That's just integrated circuit that amplifies voltage. And in addition, the problem that brought us here is these, if you did everything correctly, 28 capacitors in this bag. Capacitors don't cost much money. So all these might have costed Harman Kardon in mass production maybe 2 to 3 euros. All the replacement parts I bought here cost me, including shipping, about 13 euros. If I would have done this in mass production, I would end up with something like 5 to 8 euros for all the capacitors in here right now, where these might cost 2. So really there's just a difference of some euros between putting shitty capacitors inside and putting these capacitors inside. I haven't talked about this before, I think. So these are Capxon. There are thousands upon thousands of cheap Chinese manufacturers for capacitors. You don't even have to know the names. If you see a capacitor of some brand like Capxon or some other brand that you don't know, it's most likely shit. Of course they meet their values, but you have no idea how much they're gonna last, when they're gonna fail, how they're gonna fail. So this is what happens here. It might happen after 3 years, it might happen after 10 years, it might happen never in your case, but these amplifiers really most likely fail due to these capacitors. And it's just a thing that is like programmed in. So it's not like they fail because we had a bad batch of them. They fail because they are manufactured to a very poor standard. So they last a couple of hours, a couple of 100 hours under operating condition, but then they just fail. And Harman Kardon, of course, knows that. They don't design a power supply for the first time. And they don't put these in because they need to save €3, because you're going to pay some €100 for this unit. So they would have all the money to put proper capacitors in there. But they just don't do that because, of course, when this unit fails and you, for example, would not know this video, or you know this video but you still are not confident that you're going to do this repair, you just end up buying a new Harman Kardon, most likely, amplifier. And this is just how the industry works nowadays, which is, in my opinion, quite sad, but nothing to do there. What I would maybe just do is not buy this or not buy a Harman Kardon of this form factor anymore, because I'm not sure what they are on the market right now, but most likely they have some similar thing like this, maybe some follow-up, but they are not going to change their policy. They will always build these things not down to a price, but to a specific lifetime, and after that lifetime it's supposed to fail, and then you're just going to get a new one. That's the idea. So what I try to do with this video is work a little against this, so to get you into a position where you could possibly fix this yourself, keep using this amplifier. One thing to note here is the capacitors I use are Nippon Chemicon or Europe Chemicon or Panasonic. In both cases, more or less their highest series, highest quality series. I don't know the exact names. For example, most of the Europe Chemicons are LXZ series. I don't even know off the top of my head how the Panasonic series is called. But these things are manufactured to be more or less the best capacitors on the market. I'm not talking about audio, feel, whatever. These are just electric components that serve their purpose very well. And they are tested and they are guaranteed to work, most of them here, to 10,000 hours at 105 degrees Celsius. And since this is not running at 105 degrees Celsius, they will live for 50,000 hours maybe operating. So I can definitely say that this unit will never fail again due to these capacitors. It might be the case that the CD drive gets stuck after some time, that the logic processor died, or that there's some firmware issue in the future. But one thing you can be sure, when you do this repair and you use the same or equally good parts as I used, it will never have this failure mode again. So the capacitors in here, they will last more or less forever. They will keep running and running and running. So as long as all the logic in here also survives, you can be sure that this puppy is going to serve you very well for a lot of more years if you wanted to. And this is what I like you to, this is why I did this video, this is why I do these repairs, because I want people to be able to keep using their devices if they want to. If you don't like it anymore, you can buy a new one, but I don't see the idea that it has to fail after 3 years to get you to buy a new one. It's a solid amplifier. If it serves your ears well, you're good to go. And I hope that many people, or at least some people, see this video, get the repair done, and revive their HS250 or HS200 receiver. So, all this being said, I now try again to put the top cover on. I didn't expect this to be such a problem, but okay, start again from very high, go lower and lower, and it actually does not want. Okay, now there is a flat line all the way here, there is no gap. Make sure this is the case. And what I would do then is start at the back to keep it from coming to the front again. But there's one thing I missed again. There are clips also here, and these of course need to go beneath the plastic of the front. So we have to unfortunately get it up one more time, get these clips beneath the plastic on both sides, 2 of them, while still trying to get it on here without any gap, which apparently is quite hard, but there we go. Then I will turn it around and start with the screws around the outer frame here. And now it's also very important not to screw them in all the way, because especially the top cover can be bent easily, and also is bent in this case. You can see it here. You cannot, no you can. So make sure to bend it to the correct orientation, then put the screw in to hold it there, put all the other screws in. Not tighten them up, just put them in far enough to prevent the cover from sliding back and screwing with your nice slot here. And then I'll actually go further on. So leave the screws like they are right now, then turn it over, and then do the 4 screws here. And again, the metal part has bent quite a lot, so you have to bend it back to get the screws where they belong. Again, don't tighten these just yet. Some people tell you that there's a specific order or a specific geometric code in which order you put screws in. For me that never played a really big role. There is this rule that you shouldn't tighten them up in the beginning, because really when you do that, your last screw is going to be misaligned and you have to undo them all again. But a specific order, I don't see that happening. So once you have the last of these 4 screws on the bottom in, you can tighten it up. You can tighten the 5 screws on the back. And since this is not a properly scripted video, you might have noticed that we forgot to put in the screws, the 3 black screws holding in the logic board. But this is no problem, they are accessible from here. So just if you have also forgotten it by this time, screw them in like so. And I would say there you have it. This is the Harman Kardon HS250, restored to its old glory, if you want to call it like that. And just because I spent more than 2 hours in doing this, what I'm going to do now is connect a stereo set of equally crappy speakers as before, but in a nicer housing, to the 2 outputs of this amplifier. Hope that I get the connections right, because otherwise you will think that I didn't really repair the amp. So there you go. Get its power cord or some other matching power cord, put it in there, turn the unit on, wait until it eventually reads its CD drive, recognizes that it's actually audio CD, and it's actually stereo, and it's actually able to play that back. I will start with 0 volume, which is always something you should do, because you never know how the speakers are set. And there you go. You get sound from both sides. And again, I would like to show you some more of the audio that this amplifier is outputting. Not that it would have any really use to you, but just to show you some more that it's working. But since every CD is under some copyright protection, I can only play a couple of seconds of sound. So I'll just wait until the second track comes in, turn that up once more, and then we're good to go. So, there's this track, running perfectly in stereo mode. This is your repair. Again, I hope you found this kind of interesting and it helps you if you do this repair on your own. Thanks a lot!